Look at, of course, love it, geometry, the geometric definition of a parabola. So meaning, how is the parabola defined using this new vocabulary, focus, and directrix over here? The equations, of course, and we're going to draw some, and you know I can't not do a word problem. Come on, right? Okay, so parabola, and I wish we had color copy machines because it looks so much nicer in color on mine. So of course a parabola, you can read it at the top, set of all points in the plane equidistant from a fixed point F, called the focus. That's our new exciting point we're going to find. And a fixed line called the directrix. So if you look in my picture, which is color-coded, so of course, I'm going to do blue here. Here's my directrix line, and then you have the focus. Now notice, the vertex, you know what the vertex of a parabola is. It's directly halfway in between the focus and directrix. So that's kind of nice. Once you figure out the distance, you can discount. If the focus is 2 units from it, the directrix is 2 in the opposite direction. So you can just equally count the space. Now, we also know, so many lines in here, I'll tell you, I usually do draw the axis of symmetry, the line that goes right through the middle of your parabola. So you fold it over, it matches up, it's symmetric. I don't necessarily always draw when we have to do directrix because I feel like you have so many lines on the picture, it turns into a hot mess, okay? So I don't necessarily always draw the axis of symmetry on just because it's kind of a mess on there. Now, vertex, of course, we just talked about that, halfway. And I'm going to show you how to calculate it in a minute. There's a little formula for it. Axis of symmetry goes through your focus. And it's perpendicular also, just for information purposes, to the directrix. Okay. So, little twist on the equations. You're probably used to, like from Algebra 1, seeing y equals x squared plus 4x minus 6. I don't know, making up equations. These are going to be in a little different style. The x squared, notice, is on the left. So this is in what we call standard form. Just a little note here. And we're going to write all of our parabolas in standard form. Now today, the first lesson, the introductory lesson, all of the vertices are going to be at the origin. Clearly, they can move around the graph grid. We will get into the shifting, or the moving off 0, 0 in another section. But for today, kind of nice, your vertex is always at the origin. So you can't beat that. Now, notice too, they talk about this p-value, or you have this 4p in here next to y. Now, p is super important. That's always going to be one of the first things I find, because p is the distance, my little side note here, from the vertex to the focus, or the vertex to directrix. Because remember, the vertex is in the middle. So if I figure out p is 2, I'm going to go up 2 and then down 2. And I can equally draw the directrix and my focus. Piece of cake, I've got it. I'm also, just because I really want to say this, I can also use p to help me find what's called the length of the lattice rectum. So that is kind of the width of the parabola. Yep, I'm going to say rectum a lot in this section. Get excited, everybody. So, So that also, I think, is a little easier actually to help draw the parabola than making a T-chart and getting some other points. I'll show you that. Now, you can see all of this stuff here. I don't like to memorize all of this. As you know, math, patterns, common sense, okay? What I worry about, of course, is figuring out what P is. Common sense. If P is positive, it opens up. Shocker, who would have thought, right? P is negative, your parabola should be opening down. And then once I have P, I can count to the focus, I can count to the directrix. Focus is always inside the parabola. The directrix is on the outside of the parabola. Okay, so let's just kind of, we'll warm up here, we'll warm up. Not to the drawing, yeah, I thought I'd break us in before I have to do my artistic skills. Find an equation for the parabola, vertex 0, 0, and our focus is at 0, 2. So the first thing I'm going to do is just jot down, because today we're looking at the vertical ones right now. My x squared equals 4py. We haven't done the left and right ones yet. We're on the vertical. Now, I'm kind of a visual person, so I'm thinking about, okay, so if I've got this parabola, 0, 0 for my, and my focus is at 0, 2. So the focus is always inside of it. So it's going to look something like this to make the focus be inside. So I'm like, okay, good to know. Opens up, so P should be positive. This lead term better be a positive or something bad has happened. And I can kind of figure out what P is. Remember, P is the distance from the vertex to the focus. How many units are you between the vertex and the focus? We're 2 units, right? Between here, we're 2 units. So all I have to do for my equation, this is really exciting, put a 2 in there for P. What's 4 times 2? There's your equation. So just kind of practicing that vertex to focus distance, because I'm going to use it to draw in a sec. Okay, here comes the drawing skills. Okay, find the focus, director, sketch the graph. First, we got some problems. I do not like that equation. It's not in our standard form. I need the squared, the x squared on this side. So first I'm just going to do a little swap. I'm going to flip them. I'm going to use my, here for geometry, my symmetric property of equality. Remember that from proofs? Nobody's excited. Okay. And of course, I don't want a negative here. I'm going to switch the signs. So that first is just getting my equation in standard form. Next. How is it going to open? Up or down? Press your gut. Look at your coefficient. Down. The negative is going to tell you down. We know the vertex is on the origin. So I can start with that. I know it's going to open down. Now I need to know what P is, because P is the distance from my vertex to the focus and the directors. So 4P, of course, I'm going to to my little board here, is of course representing that coefficient in front of y. So I'm looking at this, I'm like, okay, what's the coefficient on y? -1. Oh, good, I gave you a fraction. You're welcome. P is -1/4. Now, I don't get so much carried away about the fact that it's negative. I mean, the reason it's negative, of course, you're going to go down because you want the focus inside our parabola that Avery told us was going to open down. I don't know why I made a 4th. That was really bad planning. So I'm going to go down a 4th. Oh, gosh. I don't know. Focus. That's an F, a very slubby F, okay? Now, to do the directrix, you're going to go the opposite way, a 4th. So from the vertex, I'm going to go up a 4th. Really regretting this. And so picture it. I haven't drawn it yet. I'm going to have this parabola opening down. I'm going to show you a hack here in a minute. Now, of course, my directrix then is a horizontal line because it goes away from your parabola. So 2 things I'm going to answer before I finish drawing. I've got the focus, which is at 0, -1/4. What an awful fraction, right? I've got my directrix red line on there. Now it's a horizontal line. All horizontal lines y equal. And you know, if I could draw straight, we went up a 4th. Now, a couple ways to get the parabola here. And I'm going to show you my pro tip, the easiest way to do it. I could make a t-chart, an xy chart, and plug in points and try to get some other points on it. I don't know if I really feel that, right? If I want to go to my calculator, okay, I'd have to punch that in, so, you know, hit graph, second tail, okay. Now, it is coming up in a future little example. I'm just going to start using it now. And plus, I like to say length of the lattice rectum. So, yeah. So I'm going to show you from the first point how to do the length of the lattice rectum and what that is. Your length of the lattice rectum, I just want to write rectum up here, is whatever you get for 4P. Oh, I got it. 4P's. I'm just going to look at the 1. I don't care about the negative. So what does that mean as far as drawing it? This is so bad, the fractions. So the length of the lattice rectum goes through the focus, and it has to be 1 unit wide. So from the focus, this is the worst fractions ever. I'm going to go a half to the right and a half to the left and make it 1 unit wide. Now, I could have done a t-chart. I could have put in my calculator. There's lots of other ways to get the graph. But personally, Little quick, easy hack on that is to just use the length of the lattice rectum, which I'm going to start using now because we're going to use it in the future. Some books call it the focal diameter. I just like to say lattice rectum. Okay. So let's do the left and right, the horizontal. Just when you felt good about those. So y squared, which is kind of to me, it like twists my mind around a little bit. Because we're used to, of course, I look at that first variable and I think that's the direction of how it's going to open. But I'm like, oh, why? No, it's not up and down. It's left and right. So these are our left and right ones. Vertex is still at the origin. Same thing. P, same calculations. You're going to have the 4P in it. Distance from the vertex to the focus. Vertex to the directrix. It's the same thing. Common sense. Right if P is 0. Left if P is negative, okay? Common sense, same stuff, just left and right. So you have to really keep straight in your head. X squared is your vertical, y squared is the horizontal. It's kind of twisted or backwards, so to speak. And I'm going to show you your calculator how to do it in here. I don't know if it's worth it, but I'm going to show you. So, and like I said, some calculators have it, some don't. So first thing, probably has even been doing. Find the focus and directrix, sketch the graph, look at your calculator. Okay, let's do it. So I don't like that we're not in standard form. You're going to have to write them in standard form. All that means is the squared term should come first. Oh, okay, so I'm going to subtract 6x, whatever. Now it's y squared, so horizontal, and it's negative, so left or right. Which way is it going to open? Left. Now, does it ask me that? No. But I'm just going to make a little mental note here. Opens left. Okay. And our vertex is on the origin, remember. It will move away from the origin at some point. Now, the most important next calculation I need to figure out is that 4P, because that's my distance for my focus, directrix, etc. So remember, this coefficient, your first coefficient on the right side represents your 4P. And then I'm going to have to do a little solving here. I'm going to divide off 4. And that's negative 3 over 2, negative 1.5. That'd be a little easier way to think of that. Now, the focus is inside the parabola. The parabola is opening left. So the first thing I'm going to do is go left 1.5 units from the vertex. Left 1.5. That's not so bad. So there's my focus. So I'm going to draw it here eventually. We'll open that way. Now, the next thing I'm going to do, because I need the directrix, so I go the opposite way 1.5. And it's going to be a vertical line because your parabola opens away from it. So x equals 1.5 for that. So it asks us to write these things down, so let's identify them. So my focus is this left point, negative 1.5, 0. My directrix, I'm just going to put D for directrix. X equals 1.5. Now again, to draw it, I could make a T-chart, plug points in. I'm going to show you how to do it in a calculator, but the table is not that great, okay? So I like to use the length of the lattice rectum. And remember, that tells you down there, it's your width. Segment through the focus, it's your width. And remember the calculation, it's just whatever the 4P was. So I'm looking at that negative 6. Not really the negative. I don't really care about the negative because it is a width. So I'm going to go through my focus, and I need it to be 6 wide. So I'm going to go 3 up, 3 down. 1, 2, 3. Lord help us all. That's not too shabby. I'll take it. What do you got, Riley?
Isn't the directrix 1.5?
Did I put? Oh, I forgot the 1 in front of it. It is. I said it. I just didn't write it. Thanks, Riley.
Sorry. I was checking.
No, I said it. I just didn't write it. Thank you. So that's the easiest way. I know kids hate the, because it says rectum. But to me, it's actually a whole lot quicker than making a T-chart and having to write out the points and do all that shenanigans. Now, your calculators. So like I said, this one, mine has it. A couple of my set over here do not. Most of them do. I pulled one out, this doesn't. Why, I don't know. Why they're on what models. to find it, if you go to apps, this apps key right here, and you should have number 4, maybe, hopefully. I don't know, 4, conics. Does some of you have it?
Yeah.
Okay, some no. It depends on the mode. Okay, obviously we're on parabola, so I'm going to hit 4. Now, you can see a course that's so tiny, like the top is the horizontal, the bottom is the vertical. So we have the horizontal one, so I want that top equation. Now, notice they've got like the h and k in there. I am going to talk about the h and k. Our h and k's right now are 0, because that's the vertex. We're at the origin. It will change eventually. So I'm going to go ahead and hit enter. And then, of course, you can see I punched this in earlier. So 0, 0, that's the vertex, 0, 0. Yours will all be 0, 0 today. It'll change eventually. And my p-value was negative 1.5. And you can put negative, 1 and negative 3 over 2, whatever. And then I just hit graph. And there it is. Now, I'm going to try not to go on my rant of Texas Instruments, but I can't help myself. Is the focus on there? Nope. Is the directrix on there?
No.
Try to pull up a table.
You can't.
You can't. So how helpful is this?
Not very.
I don't think it's very helpful, personally, but I thought I would do my due diligence and show it to you. Yeah. And then you just got to quit out of it. I don't think it's that helpful. Personally, I love Desmos. Desmos is very nice. You can type it in, maybe see some more points on the graph, but that's how you do them on your hoopty Texas Instruments calculators. Okay, I said I wasn't going to complain about them. Here we go. Find the focus, directrix, all that good stuff, sketch the graph. Okay, let's do it. So first, squared term has to be on this side. So I'm going to flip this around. I'm going to put the half x squared over here. Okay. Next, you got to do a little algebra. I want it just x squared. So get rid of the half for me. You're just going to times by what? 2. Okay, so x squared. How is it going to open? Up, down, left, or right? Up. The x squared is the vertical, positive 2, so up. Does it ask you for that? No, but I'm going to put a little note. Okay. We know our vertex is 0, 0 today. It'll change eventually. Now remember, the coefficient on y is what 4p equals. So I'm going to divide by 4, we get a half. So to mark out your focus, you go the same direction you open, because it has to be inside that parabola. So I'm going to go up a half unit. So I'm at 0, a half. My directrix is the opposite direction, and it's going to be a horizontal line because my parabola is going to open away from it. That's a y, a very sloppy y. Y equals negative a half. Okay. Now, easiest way I think to draw it, it doesn't ask for us, but I'll show you my pro tip, is the length of the lattice rectum. You can just abbreviate LR. Or, call it focal diameter if you prefer. And that's what 4p equals. What's 4p? 2. So I need it to be through the focus to y. So from the focus, I'm going to go 1 right, 1 left. 1 right, 1 left. Got it. And of course, like I said, there's other ways to do it. You could make yourself a T-chart. I find that obnoxious. I'd rather just do the quick lattice rectum and draw it. As long as you can get the picture. Okay, you got to do a word problem, right? So parabolas have important properties. They use them a lot, like when we talk about reflectors and lamps and telescopes and all that sort of good stuff. Light from a source placed at the focus of a surface with a parabolic cross-section is reflected that it travels parallel to the axis of the parabola. I feel like we're teaching physics here again. Got a lot. So this isn't too bad of a problem. A searchlight has a parabolic reflector that forms a bowl, there it is, 12 inches wide from rim to rim, 8 inches deep as shown. If the filament of the light bulb is located at the focus, how far from the vertex of the reflector is it? Okay. Well, let's first look at this. It clearly is opening up, So I'm thinking about that first blue equation, the x squared equals 4py. Now, I don't know where the focus is on here, so I don't know what p is, but so if we think about this, of course, remember at the origin. If we think about that, I do have an ordered pair of coordinate on here, because you have all these values. I can tell you the ordered pair of this point at the corner, because 12 is the width. I could go over 6 and up 8. Because 12 is the total, right? 6, up 8. I mean, you could go to the left, I guess, -6, up 8, but whatever. So I'm going to put 6 and 8 in for x and y. Because remember, I need the p. I need the p for the focus. That's what they're asking to figure out, really. So I'm going to put 6 in for x, 8 in for y. Okay, let's solve for p. 6 squared, got it. 4 times 8. And then divide by 32. Okay, reduce that down. What's 36 over 32, really? 9/8, yep. Reduce it down. And I think we know what we need to know to answer this. So it says, blah, 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 if the filament is located at the focus, which we now know, how far from the vertex is it? How far from the vertex is it? 9/8, and I'm going to be fancy and throw a label on inches. Yay! And we're done. Good. So just a fancy word problem asking you to find the focus. That is not that traumatic for a word problem.